Math is a wonderful thing. Math is a really cool thing. So get off your ass, let's do some math. Math, 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 math.
Integrating maths with economics. What is integration? It is more than just finding an area under a curve. Integration lets us find continuous sums of functions. Here we have a table with functions of x that we will be integrating to show how they will end up. X to the power of n will become x to the power n plus 1 over n plus 1 plus c. A will become ax plus c. E to the power of ax will become e to the power of ax over a plus c. And 1 over x will become ln x plus c. Maybe you're wondering why there's a plus c at the end of every function. This shows there's a constant on every single function, even though you might not know what it is.
Rules of integration. Linearity is the integral of a times f of x plus b times g of x equals a times the integral of f of x dx plus b times the integral of g of x dx. Next is a substitution rule. By the integral of g f of x times f dash of x, you set u equal to f of x and the differential of u to f dash of x. Therefore, the integration becomes the integral of gu du.
Uses of integration in economics. The main use for integration is to find the area under a curve. So within economics, we can look at two different curves. This first graph shows total revenue and total costs. The shaded area shows the difference between total costs and total revenue, which gives profit. 2c equals 2r to find out Q1, Q2, P1 and P2. To work out profit, we integrate total revenue between the limits Q1 and Q2 and minus the area under the total cost between Q1 and Q2, which is the area of a trapezium, which is half AB times H, which is P1, P2 over 2 times difference between Q1 and Q2. This graph shows a simple supply and demand curve. Here you can see the equilibrium price PO and quantity of QO. To calculate QO, put the function for S and D in terms of Q equal to each other. Rearrange to find Q, and then put Q into S or D function to find PO. The shaded area here shows the producer surplus. This is the benefit gained by suppliers by selling equilibrium Q at equilibrium P. The top shaded area here shows consumer surplus. This is savings gained by buying equilibrium Q at equilibrium P. Consumer surplus equals the integral of the demand curve for the limits QO and O minus PO times QO. Producer surplus equals PO times QO minus the integral of the supply curve with the limits QO and O.
We use integration by part when we have two functions of x that we cannot integrate as one subject. Let's look at this example. Integrate 2x e to power x. Here we have two functions of x that we cannot integrate as one. The formula for integration by part is integrate u times dv by dx equal u times v minus integrate v times du by dx. We compare the function to the formula to say u equal to x, v equal e power to x, du by dx equal to dv by dx equal e to power x. So integrate to x e to power x equal to x e to power x minus integrate to e power x equal to x e to power x minus 2e to power x, not forgetting to plus c.
Let's now have a look at an example that's a bit more specific to economics. Here we can see another supply and demand graph, so we can have a look at calculating the consumer surplus and the producer surplus. So the formula for the demand function is price equals 50 minus quantity squared, and the formula for the supply function is price equals 10 plus 6 times the quantity. As said before, to calculate the equilibrium price and quantity, we put the function for demand and the function for supply equal to each other. So 50 minus q squared equals 10 plus 6q. We can rearrange this to say that q squared plus 6q minus 40 equals 0. Therefore we get that q plus 10 times q minus 4 equals 0. For q can either be minus 10 or 4. Now as it's a quantity it can only be 4 because you can't have a negative quantity. So the equilibrium quantity is 4. If we place this back into either of the functions for either demand or supply, we get that the equilibrium price therefore is 34. Now we have calculated the equilibrium price and quantity, we can start and look at calculating the consumer surplus and the producer surplus. So let's start by having a look at the consumer surplus. So to calculate the consumer surplus, we integrate the demand function between the limits of 0 and 4 and then take away the equilibrium price times by the equilibrium quantity, in other words 4 times 34. Once we perform the integral, we find that we are left with 50q minus q cubed over 3 between the limits of 4 and 0 minus 136. So when we put these in the limits, using the limit 4 we get 200 minus 21 and a third, and using the limit 0 we get minus 0 and then minus 136 on the end. So we get the consumer surplus to equal 42.67 to 2 decimal places. Moving on to calculate the producer surplus, it's a very similar process, except we start with the equilibrium price times the equilibrium quantity, so 4 times 34, then we take away the integral of the supply curve between the limits of 0 and 4. So we end up with 136 minus 10q plus 3q squared between the limits of 0 and 4, which gives us 136, and then using the limit of 4 we get minus 88, and then using the limit of 0 we get plus 0 on the end. So overall the producer surplus turns out to be 48.
Thanks for watching.